Just type in the chat who, okay, just type in the chat who is in your group, okay? Just so I know, can you guys all type in the chat what group you were in yesterday? Or, fuck yeah, you're the only one here. Okay. So good luck on your presentation by yourself. Uh, Hopefully everyone will show up. But if they don't show up, well, we can do presentations another day and we can go over some content today. Okay, no worries, Harshika. So I'll fill you in a second. Let's see, who here has their entire group with them, or at least the person who has the code? Okay, write in the chat if you have your code for your group. Ritvik, okay. Okay, yeah. Who else? Okay, Sudden. Who else? Okay, all right, that's fine. We'll start two presentations today and then we can do the rest tomorrow. Okay, I'll start off with the content. Actually, I'll start off with presentations. Let's start off with Ritvik. Do you want to go first? Present your project for your team?
Sure.
Yeah, yeah, go ahead. Share your screen. You have, since it's not much, I'll give you like 3 minutes, if that's fine. Okay, go ahead and explain to me what model you're using, what type of data you're using, and explain the code, explain the results, and everything. And you're probably speaking on mute because I can't hear you.
This is advertising budget versus sales.
Okay.
Advertising budget is the independent variable and sales is the dependent variable. So what we did is I copy and pasted the code and we have a bunch of these libraries.
Okay.
Then we got this thing that reads the CSV and then puts it into data and then it uses that data and gets into columns into two variables. Then once we have those two variables, once they train the model and it fits here,
Mm-hmm.
then it predicts, and using that predict, it actually makes this line that you see down
Okay.
here.
What equation is it using there? Remember?
No,
Remember from our inference y hat
I think it's
equation?
oh yeah, it's mx plus b,
Yeah. Yeah. Y hat equals wx plus p, right? Yeah. Good.
and then it calculates the slope and intercept, and then it prints them down here.
Yeah. Okay.
And then this is all just making the actual thing. And
Good.
I can change color.
Okay. Go up on your code. Now explain to me what each library you imported is used for.
This is for actually reading the thing. This
Okay.
is for actually plotting it.
Yes.
This is for calculating the linear regression.
Mm-hmm.
This is for I think
Remember
training
what
the
this
actual
equation
model.
is?
Huh?
What? Remember this equation, mean squared error, your loss function. Remember?
Yeah.
Right. Right. Go down to your results. Now, to your results. Yeah. Explain to me what the slope here and the intercept, what they mean. Just be very vague about it because obviously you don't know what it means until you can compare it with something else, but just be very vague about it.
Well, the slope's kind of like the degree of ascent that it goes up. So as we see, like it, there could be a line that goes super high up or super low down. So this slope tells us like how high or down it is. And the
Okay.
intercept is basically where it hits this little line. So since it just stops here, but if it kept on going, it would be hitting here, and it tells us the exact point where it's hitting this
Okay.
y axis.
Okay, good. Okay. What else do you need to expand? Go up. Yeah, good. Good, good. Okay. MSC. So remember, mean squared error, the goal of that mean squared error is to minimize it as much as possible. Therefore, you can get the most accurate response, right? And
Yeah.
your MMB value, those are your parameters, right? And you're getting those parameters using the mean squared error and your gradient descent function. Okay, good. Next. Sudden,
Yeah.
explain your project.
Okay. Let me share my screen.
వివేక్ ఇది వాల్యూమ్ సరిగ్గా రావటం లేదు.
Okay, guys. So you can see this is my graph over here. I used a linear regression model. So this line of code right here, this basically loads the set, so the data set, and this line of code is the x and y axis. So this part, and this is like the y hat equals wx plus b equation, and this I kind of forgot what this does.
That
Does
trains your
this?
model. That
Okay,
trains your
yeah.
model. So this is
Yes.
where your mean squared error function comes in. That
Oh,
trains your
right,
model.
right. So this is the loss function.
Yeah, so this will perform your loss function and your gradient descent, and that's
Okay.
what it's training the model based on your parameters. Look, go up. It's
Okay.
okay. Look, x and y, right? Where you're defining x and y, right? You're creating your data columns, x variables, all your data points for x, it's being fed in, and then all your data
Okay.
columns for y is being fed in. Remember, in the equation of MSC, you're having your input data, right? You're feeding it in, and then it's getting the most optimized parameters from what? The gradient descent. Then the gradient descent goes in and trains the model, and then you're getting the parameters, and it's being used for when you actually predict it. But what that fit does is it's running the MSC and it's also running your gradient descent. Okay? Yeah, continue.
And I forgot what this does. What does this do? Does this also train the model?
It doesn't
Or
train it predicts it.
so is that the line? Is this the
Yeah.
line?
So this is
Okay.
where your model is implementing the y equals mx plus b, y hat equals wx plus b equation here.
Okay. So yeah. So this is the line of best fit. And over here, this like prints the model. So this is how we got this graph. And this is basically like not really, it's just coloring and like labeling everything.
Okay. To fix
It's not that important.
sentence, you made a small mistake. The print
Yeah.
functions, it
Mhm.
prints out the slope and the intercept. You see where it says slope and intercept? That's
Yeah,
what
yeah.
this code does. And then the code
Okay.
underneath, it actually prints out the graph. And then you can edit the graph to however you want to look like. Stylistic. Okay, good.
Okay. Okay, no. Yeah, is that it?
Yeah, that's it.
Okay. Thank you.
Okay, good job. All right. Cool. Does anyone else have the code for their group? No? No one else? Okay, no worries. All right, what we can do is I'll start with okay. I want to hear you guys' opinion. Do you want to do a refresher on linear and logistic, or do you want to move on to the next topic? Then we'll be ahead of schedule by a bit, but what do you guys want to do?
Move on.
What does everyone think? Write in the chat what you want.
I have a quick question. Would we actually need to know the formulas for linear and logistic regression when we're coding? Because we could just
When you're coding, no, but you need to understand how it works because if there's ever an issue, and for example, you're creating your own model and you want to like fully from scratch, you got to understand this, right? And it's useful when you're writing papers or anything because you need to know how everything works to explain what you did. And also, another reason why you need this is because there's this thing in machine learning called the black box, okay? That's basically we're saying the outputs of whatever the machine learning or AI model tells you, we don't understand it. That's what the black box is. And we're trying to minimize that black box. So by creating stuff that's explainable, you're reducing that black box. And why this is important is because if you don't know why something is giving an output, then it could just give you an output that's entirely wrong, and that could like have negative consequences. Okay, so that's why it's important to know the equations and how it works. But encoding wise, you don't need to know that much because everything's almost done for you. But once you get into neural networks, yeah, you need to know the equations, or else you'll be so lost in how to make a good model. Because without the proper equations like knowledge, you won't be able to create a good model. But for the basics of machine learning, to be honest, you don't need it that much. Yeah. Does that answer your question?
So for the rest of this class, in your opinion, do we need it for the rest of this class and all those projects?
I mean, I think I'm starting deep learning either next week or the week after. So you definitely need to know it then. But for now, I mean, the equations aren't too difficult anyways, but you need to know at least the basics of how it works. Like you don't need to memorize the equation per se, but you just need to know, okay, what does the loss function do? What's the goal of a gradient descent? What's the goal of your prediction, right? You need to know the basics of that. You don't need to memorize, oh, the loss function is blah, 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 right? Summation or whatever, right? So you don't need to know that much. Okay, let's move on since everyone wants to move on, and I'll have to go over this again anyways next time. Okay, today, yeah. Okay, let's get started. Okay, so today we're gonna learn about decision trees. Okay, let's get started. Okay, reminder, please ask questions. All right, I'm here for you. So make sure if you don't understand the concept, it's okay to speak up and ask questions. Okay, no one's gonna judge you or anything, so please ask questions. All right, so what is decision trees? So decision trees are models that make predictions by splitting data into branches based on feature values, leading to decision outcomes at the leaves. Okay, right now what I said doesn't make any sense because I just kind of sprouted out the definition, but let's understand what that means, okay? Let's see. Okay. Decision trees. Let's take this example here, okay? A student would like to learn about AI. Okay? If that's true, he takes this course, this workshop. Okay? If that's not true, he plays Roblox. All right? So you kind of get a general sense of how decision trees work, right? We have a statement, and the model, if that statement is true, it goes and performs this. And how they usually work is that there's usually another question until it keeps asking questions and creates a tree structure until it gets out its output. Okay. Um, I'll go more into it, but this is just a general idea of how a decision tree is laid out. So, sure. Okay, good. Okay. Decision trees make decisions based on whether it accepts the statement or not. Okay, so basically what I just explained, there's a bunch of statements, and if it chooses to accept that statement, it goes on to a different branch, and then it keeps going on until you get the final leaf. Okay, so the leaves are these green things, so that's the output, and the branches are these. Okay, all right. So the decision tree classifies. Okay, so if a decision tree classifies into categories, it's called a classification tree. And if it predicts numeric values, it's a regression tree. Okay, what does that mean? Right? What is classification trees, regression trees? Right? So far we've been working with what? Regression, right? Linear regression, logistic regression. Now, for example, it's a classification tree. A student would like to learn about AI. True, false, he takes this workshop or he plays Roblox, right? It's making a decision based on prior, knowledge and different things like that, makes its tree. But if it's a regression tree, the goal is to like predict some values, right? For example, a normal 17-year-old boy goes on a diet. He weighs between some pounds. And then if it's false, he weighs between 150 to 160. Okay. The goal of regression trees is to predict some numeric value, right? It's something that you would need in those types of situations. But for classification tree, usually using it for, well, I can't really say classification purposes, but that's exactly what it is. It's for predicting some outcome. But for this, it's specifically on numeric values. Okay. Let's use this data set as an example. Okay, we have 3 columns: weather, temperature, and play outside or not. All right. So all of these are categorical data. We have weather, sunny, overcast, rainy; temperature, hot, mild, cold; and then play outside, no or yes. So binary values, no or yes. Okay. So now let's create a decision tree. All right. So my first question would be, is weather equals sunny or rainy? Okay. And if it's false, you see how the decision tree filtered it out. It filters, okay, let's look at the data and see what false would be. False would be overcast because that's neither sunny or rainy, right? It's cold and play outside, yes. Okay. Now, if we look at true, we have all of these. The goal of this tree is to filter it down until you get play outside is yes. Okay. That's the goal of this tree. So now, if the second question, play outside equals yes, false, it's no, and yes, it's there, right? So we got our outcome that we needed. We filtered it down where it's yes on both sides. Okay. I'll explain more on how you can build a tree. So there's one method you can use to build this tree. It's called Gini impurity. Okay. So how can we ask these questions? How does the AI model know what questions to ask and how to filter these down, right? So we can use this method called Gini impurity. Let's go right into how we can use this method, right? So in this case, let's use this example data set. We're going to use a 10th class homework study hours, pass this or not, okay? So now we're trying to filter it down to see if they pass or not, right? Let's see how we can use this Gini impurity method to do that, okay? So this is how our final tree would look like, okay? A 10th class, true, false, right? We have our tree here. So let's say we never seen this tree before, okay? Instead, we're given this data and we need to now know what should be our first question that we need to ask. So how can we do this? What could our first question be? 10th class homework study hours. Okay, I want you guys to tell me what you guys think on the chat. What do you think? Your best guess. You don't have to use any method or anything. Just give me your best guess based on the data you're seeing, what the first question would be. Go ahead and answer that in the chat or speak out, and we'll find out if you're right. Let's see what our answers are. Okay. 10th class, okay. Did they attend class? Oh, right. I just realized I showed you the tree before this. But I actually changed up the tree, so it's not the exact same. But, okay. Okay, all right. Good answers. Good answers. Everyone says class. Well, we'll see if that's true or not. All right, let's go. So to do this is not the correct answer, by the way. Okay, we're just gonna start with the tens class because that's the first thing. To do this, we'll start with a tens class and see how that affects if you pass or not. Okay. So let's make a simple tree to figure this out. So we created a decision tree, right? We have a tens class, true or false. And now we're checking in each one, we're creating a table of values. And in this table of values, we're seeing if how many people say yes when it's true and no when it's true as well, and then check how many are yes and no when it's false. So let's look at the graph, right? So a tens class, true. Okay. A tens class, yes. Okay. Now, does he pass? Okay, yes. So we have one yes. A tens class, false in this case. Passes? No. Okay, so we have one here. Okay, so 1, 1. A tens class, yes. So that's true. And passes? No. Okay, so now we have these values. So right, one pass, one no, and one no. Okay? And a tens class, yes, passes, yes. So now we have two yeses for true, one no for true, and for the false side, we have one no. Okay? So now we created our decision tree for a tens class area, right? Now let's do the same thing for homework. All right, we do the same thing. And now that we have these both, we can notice that they're both the same, okay? But let's just take, for example, that we just make up some values just for this example, so you can see how gene impurity works, okay? So if you notice, right, what is pure here? Well, what does pure mean in these types of leaves, right? We check the leaves, and if they're completely zero on one side and have some value on the other side, that means it's pure. For example, pure leaf would be this leaf right here, right? In yes, it's 0. In no, it's 1. So it's pure. But if you look at this blue one here, in true, right? In yes, there's 2, and no, there's 1. So it's impure, right? It's not pure. So then we can perform something like gene impurity. So before that, how can we quantify the differences and find what to use, right? Now the goal is to what, right? We're trying to figure out what the first question is, right? How can we do this? Well, let's find out. Right. So I just explained impurity. The final nodes are the leaves here. Those are the impurity. Let's go. Okay, so let's use the gene impurity method. All right. Let's start off with this left leaf here for homework. All right, let's see. And we do an equation called gene impurity on the left leaf. So what is that equation? That is just 1 minus the probability of yes squared minus the probability of no squared, okay? Or you can just see it in the equation form right here. All it is 1 minus summation, and like we discussed in the last class, I'll just quickly do a reminder. All the summation is, if you see pi squared, that is just the probability here. So in this case, we have 2 leaf nodes, so we just do the probability of yes squared, and then if it's a summation, we have 2 leaf nodes, we just add it up again. That's it. Okay. Of no squared. Okay. Let's say there's 3 leaves, then you do probability of whatever that leaf value is squared. Okay. And we can keep doing this for how many leaves we have. That's all a summation is. It's nothing too complex, but that's all it is. Okay. So we then, we do a gene impurity for this leaf, the left leaf, the true leaf for homework. Okay. And we get our answer. So since this is a pure leaf, right? We notice 3 for yes, and then for no, it's 0, right? We get a value of 0 anyways, right? We can also mathematically confirm this by this equation that I've put here. Okay. So now we know it's a pure leaf, and this has a Gini impurity of 0. Okay. Now we do the same thing for the false as well. So now the false is 0.48 Gini impurity. Okay. So since we have these two now, we're not trying to find the Gini impurity for this entire branch, right? We're trying to figure out the Gini impurity for this homework branch. So how can we do that? How can we assign one value for both of these leaves? Well, what you can use is this thing called the weighted average to get the true Gini impurity. Okay. So the weight is equal to the number of people in that leaf divided by the number of people in both leaves. So for example, 3 divided by 3 plus 5, right? Because there's 3 in yes, and 2 plus 3, 5, right? And we do 5 plus 3, which is 8, or 3/8, right? So the weighted average there is 3/8. Now we do here for false, we do 5 plus divided by 8, and we get 5/8, okay? And now what we can do to get the total Gini impurity is now we can multiply it by that impurity. So we do 3/8, which is the weighted average, times your impurity for that leaf, which is 0, and you do the same thing for the false one as well. You do 5/8 times 0.48, and you get 0.3. So then you do a summation, right? You do 0 plus 0.3 equals 0.3 as the total Gini impurity for this branch, okay? Now we just do the same thing for both of them. All right, 0.3 Gini impurity and 0.333 infinitely, right? Gini impurity for the attends class. Okay. Now we have these two values here. Okay. And remember, our goal is to have the lowest Gini impurity as possible. So you want always the lowest Gini impurity to be your base question, right? Because that's your strongest one. That's the one that you can filter down the most, right? That has the most pure leaves possible, right? Because if you have the most pure leaves, that means you have the most data that can filter everything down properly, right? So the goal here from now on, you'll see after this how you can use it, right? But it's going to be the pure leaves. So now we need to do hours. Since hours is numeric, we use another products. Because remember, these are categorical. So we do the method of the categorical way, right? But since these are numbers, they're quantities, right? We need to use a different method. So how can we now calculate the Gini impurity for this, right? Because we can't just put it in groups, be like, oh yeah, 15. How many 15s are there? No other 15s, right? So we can't categorize them. So how can we do this? Let's figure that out. So we have these three. Oh, did I go back a slide? Yeah, I did. Okay. Okay, first we need to sort. Yeah, okay. Yeah, we first need to sort this data by study hours. So if you notice, I've sorted this out by your study hours. So it goes from lowest to high. So now it's 3, 6, 10, 15 instead of 15, 3, 6, 10. So I just sorted out the list. So that's the first step we need to do. Sort your list, okay? And now we need to calculate the age for all adjacent values, the average age, right? So the formula for that is pretty easy, right? You just do 3 plus 6 divided by 2, right? So 3 plus 6 divided by 2, you get this value. 6 plus 10 divided by 2, you get this value. 10 plus 15 divided by 2, you get this value, right? It's just finding the middle number between these two values, so that's your average. And you need to do it for all adjacent values, or basically these two, these two, these two, right? 3 times. Okay, now that we calculated the Gini impurity, let's create our tree, okay? So what we're doing now is we're just putting a number, like study hours. is less than 4.5. So now we look at 4.5. We're seeing what numbers are less than 4.5. We see no other numbers are less than or equal to 4.5, right? So the only number that is less than it is 3. So we can now take this 3 and check. Okay, what is it? No, right? So now that's true, and no, that's correct. Okay, now let's see what numbers are greater than 4.5. Let's see. This is false, right? So now 6, 10, and 15. They're all greater than 4.5. So since they're greater than 4.5, what we can do now is now categorize them, right? So 1 no and 2 yeses. 1 no, 2 yeses. Okay, we've done this. So you see how we can now do the same steps we did before? We created the same tree that we have done before and created this. Okay. And now we calculate the Gini impurity for each leaves, right? So I'm not gonna do the same steps again because I know you guys already know it and you don't want to hear me speak a lot. So we're just gonna go ahead and calculate the impurity, right? We got the 2 impurities we calculated here, and then the total impurity would be this value here. Remember how we got that? We got the weighted average times it by whatever these values are, and then add them together, and then we get our total Gini impurity. Okay. Okay. Now we just repeat for all of these values. And since I know you guys don't want to see all the equations, I just created some made up values for the rest. So these are not actually the values. I just created some random values that make sense for this this test. So let's do that. Okay. So now we can take a look at the lowest impurity score and use the values corresponding to it. So in this case, 8, right? So we take this since it's the lowest, right? And now we can set it on our final tree. So if you now look here, right? Since now study hours has the lowest Gini impurity, it goes on the top of the tree, right? Whenever we create our decision tree now, we can now put study hours on the top because what does it have? Has the lowest Gini impurity. Okay, that means it has the most amount of pure leaves. Okay, so now that so now this is on the top. This is our top branch, right? Now we got to figure out what goes next. So like, what's our next question, right? So let's figure out how we can ask our next question. To do that, we need to calculate the Gini impurity for the 2 outcomes. Okay, homework and classes. Okay, so we need to calculate them for both. So let's go. Whichever is the lower one, right? Lower Gini impurity takes that. So now we do the same thing for this for homework and classes. Okay, let's do that. Okay, so we got past 2, no, and then 0 for no. Okay, 0, 2. Okay, that's the data we got here. All right. We're just seeing for homework how many passed yes or no from the data. Okay. Since this is pure, we cannot break it down any further. So since, if you notice here, we keep asking these questions until the leaves cannot be broken down anymore. Since this is pure already here, we don't need to break it down any further because there's no need to. And it's impossible to, right? But since, if you notice before, this homework was not pure, right? There's 2 and 1. So we need to break it down until it becomes pure. And we did do that, and it became pure here, right? So that's why we need to do it that way. And since homework was the second lowest, we just put that there next, okay? In the Gini impurity. If you notice here, homework has 0.3, so that's why it goes next. So study hours is first, and Gini impurity is next. Like homework is next. Okay, makes sense why I put homework there now?
Did you like actually calculate the Gini impurity? Like, what do you have to plug into the formula?
Well, the formula is the entire, like, this whole process is what the computer does, but you need to understand how it works.
Like physical math, like which numbers did you plug into it?
What do you mean? Yeah, that's what. Okay, the Gini impurity is calculated using this formula: 1 minus the probability of yes squared minus probability of no. So you need to plug in this, right? You need to do what's 1 minus, okay, probability of yes. Okay, so there's 0 yes in this case, and we're doing, you know how to calculate probability, right? You do whatever value it is, right? How many times it passed over the total times. How many times it failed over the total times, right? So you do 0 divided by 1 squared minus 1 divided by 1 squared. And then that would be the Gini impurity for this. Then you get the Gini impurity for this. You get the weighted average for both of these. And then after getting the weighted average, you multiply it by this Gini impurity. So whatever the weighted average is here, in this case, it would be one, let me see. It'd be 3, 4. Yeah, it would be 1/4 here, the weighted average, and the weighted average here would be 3/4. Okay, so 1/4 times, in this case, it would be 0. 1/4 times 0, and then 3/4 times whatever value, add them together, and then you get the total Gini impurity, yeah, of this value here. And then you need to do that for all the table values, right? All 3 of these, and then see which one is the lowest, right? In this case, this is the lowest, so this goes on the top branch. And since this is homework is the second lowest, it goes on the next branch here. So we choose homework since that's the lowest. And now we create a decision tree, make sure it filters it down. And if it's not pure, completely pure, then we need to do the same thing, right? Next, what do we have left? Forgot. Classes. Then we would need to ask a question of classes, do the same thing, make sure it's pure, right? That's the goal. The goal is to make a decision tree where all the values are pure. Okay, and this is our final decision tree that we get. Okay, does that make sense? To everyone? Anyone have any questions? Okay. Anyone have any questions to clarify how this works or anything like that? Let's see. Did they attend class? Did they get?
Still don't understand which numbers you actually plugged into the physical math formula, not the rest of the thing. I understand the rest of it. So
You plug in the
I-
numbers that, okay, these numbers, you're asking how you plug in the numbers, right? You're just creating the, based on your data, right? This is all based on your data. So let's go back to our data, right? So the numbers we're checking here. So first, if it's numerical values like this, you have to get the average for each adjacent value, right? Then you ask the question, study hours less than 4.5. Okay, we have one value here, and if that's true, then it'd be 0 for yes, 1 for no, and if it's false, right? If study hours is greater than 4.5, then 6, 10, 15, and then you're creating this data value. And then you're using these, yeah.
Now you're calculating the Gini impurity, right? So when you go back to the oh yeah, you're on here. So you see how you have yes as 1, yes is 0. So can you like go a slide forward? No, actually, can you go a slide back wherever you calculate the actual math?
That's forward.
Okay, yeah, here. Move 0 at the very front, the 1.
Yeah.
Because on the second no part, there's no 2's, even though there's 2 yeses.
No choose.
So like plus probability of yes and then minus probability of no. But on the no
Oh
side,
yeah, I think the equation that I put in, I kind of made these ones really fast. Yeah, you're right. It's just the probability of. Oh, right. No, 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 no. Hold on. Hold on. Yeah. Okay. This one, I think I did it wrong. Let's see. Probability of yes.
what would you put in front of the dividing symbol, what do you put after the dividing symbol?
Yeah, you're right. It's actually, you're right. You do 2 plus 1
Oh,
for leaf. 1 second. Oh, okay. Yeah. Never mind. I'm right. Okay, look. So we're doing it by leaves, okay? So we do this first. Yeah, I almost got confused there. So we're doing it by leaves, okay? So right here, this is for the left leaves, okay? So in the left leaves, we only have two values, 0 and 1, right? Probability of yes in this left leaf is what? 0 over 1, right? Probability of no in this left leaf is what? 1 over 1, right? And now we do the same thing for this equation, okay, for the right leaves. We're doing it for both ones. So for the right leaf, it would be a different scenario, right? It's 2, right? Right here. Probability of yes, 2 over 3. Right? And for the no, probability of no, it'd be 1 over 3. Okay? So that's how you're getting this answer here. Okay? Yeah, okay, almost got confused there. But you're doing it by leaf. Each leaf, right? You're checking probability of yes in that leaf you're working on. Probability of no on that leaf you're working on. Okay? And that's how you're getting the Gini impurity score. And then you're creating the total score, right? Which is what? The average. You get your average of this, right? So 1/4, because there's one in this whole leaf, and then you're adding it for how many leaves there are. So there's 2 leaves, and there's in total 4 values in total. So 1/4 times 0, because this is a pure leaf, and then 3/4 times 0.33, because that's the Gini impurity for this. So then you get the total Gini impurity, which is this value here. And then you compare this Gini impurity value for all the cases, right? For all adjacent values, right? You're doing another question here. What study hours is less than 8? Study hours is less than 12.5. You're doing the same process over and over again for all your values until you're getting these values. And then you notice that's the question you need to ask is study hours is greater than 8, because that's the lowest Gini impurity. Remember, we always use the lowest Gini impurity because that's the what? The most pure leaf. Okay, so then that we set that as our question. Now we compare it for all our column values, right? We have a 10th class homework study hours. We compare all the Gini impurities here, right? And then we're creating our branch. We start with the lowest and then work our way down. Make sense?
I have a question.
Yeah, go ahead.
So how do you get 1/4 from the thing?
Okay. 1/4 is the weighted average, right? The weighted average is 1. We have 1 here, 2, and 1. So what is 1 plus 2 plus 1? 4, right?
4. Yeah,
Good.
I understand.
So the weighted average for this now is now what? 1/4, because there's one value in here and there's 4. Now the weighted average for the right value is 2 plus 1, right? Because that's the total in this leaf. 3 over the total here, which is 4. 3/4. So that's how we're getting 1/4 and 3/4. And then whatever Gini impurity we calculated here goes right over here. Whatever we calculated here goes here. And you're getting your final as this. Make sense?
Yeah.
Okay, good. All right. Anyone else have any questions? Okay. Let's see if I have. What time is it? Let's see. We have 10 minutes left. Okay. I won't. Yeah. I'm not doing the code today. Let's not do the code today because I want everyone here to understand the code later. So we'll do code tomorrow. But today I want you guys to fully understand the concept. So let's go through it one more. I want to go to the beginning of this, and then I'll just explain. Yeah. We'll start here. Yeah, let's start. Okay. So I'm sure you guys now are pretty much good on numerics, right? But I just want to review on categorical, right? So for categorical, right? Let's do this one more time. Let's make a simple tree to figure out attendance class or not. Okay, we'll start with this, right? What we're doing here. Who wants to unmute and explain what's happening here on the screen?
Wait, really
Explain
quickly,
what to say.
look at chat.
Leaf
So is
one,
that
leaves.
what I need to like put in the formula?
In the code or just to understand it?
Just understand it. Like, is that like nearly the entirety of the formula?
Yeah, yes, divided by total leaf squared. Yes, no, okay, yeah, good. Two, good. Yep, that's good. And then the second formula, so that's the Gini impurity for each leaf. You need to get the total branch, do you know, to make the final decision on what question to ask, you need to get the total impurity. And you know how to do that, right? It's just the weighted average of that leaf times that leaf's Gini impurity, and then you just add it. To add them together, you get the Gini impurity like total for that branch. And then you compare the Gini impurity totals of each branch, whatever the lowest Gini impurity is, you put on the
So
top.
you just add leaf 1 and leaf 2, like the entirety of it.
Yeah, the total. Like you would do, for example, for the example I did last time, right? 1/4. I'll just tell you. I'll write you the equation. It's weighted average of that leaf times that leaves Gini impurity, and you do a summation. Okay, so I'll just summation. So you're just adding it for how many leaves there are. So if there's two leaves, then you would add it twice. If there's 3 leaves, you would just add it 3 times. Okay.
So basically, like add the Gini impurity times the total leaf divided by total. Then we just add both of those.
No. It's like, okay, for this, the weighted average, what would it be? Right? It's 3 plus 1, 4. So the total weighted average is 3/4 here. Let's say this has a Gini impurity of 0.2. Okay. And we do now 3/4 times 0.2. Okay, I can't do that in my head, but let's just say that is a value of 0.23. Okay. Let's say this leaves now impurity is 0.23, like weighted impurity is 0.23. And since this is pure, this would just be 0, right? So 0.23 plus 0, what is that? Your total impurity for this entire thing is 0.23 now. Make sense?
Yeah, I got it. Thanks.
Okay, good. Okay, let me just explain this again. Okay. So how this tens class works, right? Okay, we'll start with the tens class here. So we're seeing how many yeses and nos are there when a tens class is true. Okay, so I'm gonna go underline all of the yeses. Okay. So a tens class is yes here, right? So let's look at them. Okay, passes, yes. Okay, so we have one pass so far and another pass. So there's 2. Okay, and there is 1 no. Okay, so now we put this down. 2 passes, 1 no. When this is true. But let's look at it when it's not true, right? When a tens class is no. When it's false, we have 1 no here. So we can just write that down as well. We have 1 no. Okay, now we put it here. Okay, now that we created this, everything is the same. It's the same steps as before. Okay, so we have the same steps. Let's hold on. Okay, yeah, we use the Gini impurity. So I'll work this out live for you guys. So let's do it. 1 minus the probability of yes squared minus probability of no. So probability, let's start with this leaves, okay? So probability of yes squared. So 1 minus probability of yes squared. So that's going to be 3 over 3, right? Because there's 3 yeses, 0 no's. So we do 3 plus 0. So you get 3 over 3 minus, okay, we have to first square this, right? 3 over 3 squared minus probability of no. Well, there's 0 and 3. So it's 0 over 3, and we need to square it. Okay, now we get this formula. 1 minus 3 over 3 minus 0 over 3 squared. Okay? And I'll just tell you right now, when you solve this out, it comes to 0. Okay? You can easily figure that out because this is a pure leaf, because there's no value for no, right? There's no like 1, 2, blah, blah, blah. It's pure leaf. So Gini impurity is 0. Now we do the same thing for the right leaf. We do now 1 minus probability yes is 2/5 squared minus probability no, 3/5 squared. Okay, you get your value, and let's see what I got. Okay, and you get a value of 0.48. Okay, that's how it works. Now, our next step after figuring out this value, is okay. Next is to do the total. So we need to now get the weighted average. So how do we do weighted average? We have 3 here, and we have 2 plus 3 here. So 3, right? Because let's start with the weighted average of the left leaf. So we can do 3 over 3 plus 2 plus 3. 3 plus 2 plus 3. 3 plus 3, 6 plus 2 is 8. 3/8. That's our weighted average. Now we do the weighted average for the right leaves, okay? So this is left leaf. Right leaf is now 5/8. Okay? 5/8 is right. Now what we can do is we do 3/8 times 0 plus 5/8 times 0.48, and then you get your answer. Okay, that's how you get the total Gini impurity for that branch, and that is 0.3. Okay, now we get 0.3 and 0.33. Okay, what's the lower value? 0.3. So this is going to be higher up on the branch, like the main branch. Okay, so that's where now after comparing it, we see that study hours is the lowest, so it goes on the top, and homework goes next, and we keep filtering it down until we get pure leaves. That's the end goal. If this is not pure, we can go ahead and do classes as well, right? Ask another question on classes, repeat the process. Okay, but that's how this works, how we create decision trees. Okay, makes sense to everyone?
Yeah.
Good. Yeah. One more thing before we wrap up. I'm sure now all of you guys are thinking, how can we use this for AI? Well, this is a type of AI model, right? Decision trees. And what it does, right? It creates these branches for your data set. And then the model makes a prediction and makes prediction based on this. So for example, you give it your data set and you're asking it, hey, can you tell me what your prediction is when I studied 9 hours and I did my homework, okay? Now it goes through this branch it creates, right? It goes through the branch. It's like, what's the first question? Study hours is greater than 8? Yes. Yes, it is. It's 9 hours to study. So, okay, we go to this one. True. Okay, did she do her homework? She said she did. Okay, it passed. So now what the output it would give is that, yes, you passed your exam as well, probably, because your study hours is greater than 8 and you did your homework, right? And for example, you give it another data set. you had 10 hours of studying, and you did not do your homework, okay? In this case, it would go here to the screen lead, and that is no. So you did not pass because you didn't do your homework, okay? Let me give you a trick question. I want you guys to answer in the chat. They studied 8 hours and they did their homework. Did they pass or fail? They passed. Fail. Okay, they failed. They failed. That's the answer, actually. So let me tell you why they failed. Oh, you guys are too late. Rhythmic, you're too late. You can't say it's fail after I said the answer. But I'll tell you why it's fail. Because it's greater than 8 hours, right? So 8 hours, it's not greater than or equal to, it's just greater than. So that's why it would be fail. Make sense? Yes. Good job. Good job, Harshika. Good job. Good job, Hanish. Yep. Good job. Everyone understands. Yeah. It's not great. It's not greater than or equal to. It's greater than. Yeah. Okay. Makes sense to everyone? Good. Now you guys understand the concepts. Tomorrow we're going to actually be building, finish up the rest of the presentations. And yeah. We'll get into more complicated machine learning projects next week. This week was just intro. So these were the more simpler models. We're going to get into more complex ones starting next week. Okay? Good. Anyone have any final thoughts, questions, comments, statements? No one?
Really
No
quickly,
compliments?
I was just recalculating the total Gini of classes. What did we say that was again? Because I got
Sorry.
two.
Wait, can you say that again?
I got two for some reason when I was calculating total Gini for class.
You got, wait, 2? Like whole number 2?
Yeah.
That's not possible at all. Wait, how? Show me your calculations. Do you have it written down or something? Yeah. Usually, yeah, that's not possible. Let's see. If one minus. Yeah, I saw your mistake. Yeah, okay, your mistake is that you're not putting 1 minus in brackets. It has to be put in brackets. Then you do whatever you get for that entire thing times 3/4. You didn't do that. You did 1 minus and you had it on exterior. Supposed to have everything inside of that. But let's see. Let me just put whatever you wrote in decimals. Let's see why. That's not okay. 1 minus. Can you just read it out loud? It's fine. It's fine. Actually, I got it. 2/3 squared minus 1/3 squared times 3/4. You got what she said you got? You got 2?
I got 0.75 for leaf 1, and then I got 1.25 for leaf 2, and that adds up to 2. The total Gini.
Yeah, I think he did something wrong. I'm just checking your math right now. 1 minus. Yeah, you did something wrong on your first leaf too, because I didn't get that answer. I know why. Because you have to put your 1 in parentheses as well. Like that 1 needs to be in parentheses. Wrap it up until square root of 2. Like the last square root of 2. That's probably why you're getting this mistake. Okay. Let's see. I'll show you what I did after 1 squared. Squared. Yeah, first of all, you should have got. Yeah, you did something wrong. I'll share my screen. But first of all, you should have got 0 for the last leaf 2 because it's pure. If you noticed, it's completely pure. But let me share my screen. Okay, this is how it should be like, and then you would add 0 plus 0.333333 blah blah blah. Okay, this is how it should be. Make sense? This can. Okay, that's how your equation should look like to be correct. Notice how this is in parentheses, right? It's not like outside of it. So that might give you your error, or you just did the math wrong somehow. But that's all. But I think you got the concept right, so you should be fine. Okay. All right. There's nothing else for me to add. If anyone has any questions, I'll stick around for maybe a few more minutes. Thank you everyone for joining. Yeah, you guys are free to go.
Thank you.
Yeah, no worries.
Could you show me the what do you call it, Desmos again real quick?
Yeah. Make sense? Ritik? Make sense?